Hey everybody, I hope you like this video today. My throat's still sore. This was the day that I was kind of not feeling that well. So I'm going to kind of do minimal talking and more pausing for you to complete each step. I did have a student ask me if I could make some jokes, to keep it funny. But I really think that I need to focus on your statistics since 11 out of 8 people have trouble with statistics. Okay, that was awful. Alright, let's try this problem. Our age and type of vehicle dependent, we observe the following observations. So we have sedan, motorcycle, and I'm just lumping everything together and calling it other. So we're looking at those numbers. We have 16 to 30-year-olds on the left, 31 to 55 and 56 plus. We're going to perform a chi-squared test for independence at 10% level. We're going to calculate the expected values. We're going to state hypotheses. We're going to check requirements. We're going to calculate chi-squared statistics. We're going to find p-values. We're going to make decisions. We're going to have lots of fun. So, why don't you start calculating the expected values here, and hopefully you remember what to do. So pause it. Okay, hopefully you have calculated the margins, because I did. So just to kind of recall how to figure out these expected values, expected counts. For instance, if we look at this cell was the sedan up here, and it was the 18 to 30-year-olds. So this represents the 45, was the 45 people in the sample who were 18 to 30 years old and drove a sedan. So we look at this and we want to find the expected value, let's say for the how many men would we expect? I'm sorry, not men. How many 18 to 30-year-olds would we expect? Then the way we do this here, what's the best color here, is we're going to take the row total. This is the row total here. Its corresponding row, so I'm going to just go all the way over there. I'm going to take that 85 and then times the column total 100 and then divide it by the table total. So that should be, I'm going to pause that, you do it too. And I'm going to round it to 40.5. So just skipping a couple cells and saying maybe I want to look at this. This was the 31 to 55-year-olds who drove an other kind of vehicle. I'm going to take its corresponding row total, which is 90 over here, times its corresponding column total, which was 80. And still divided by the table total. So I'm going to do that. What did that say before I wrote all over it? 90 times 80 divided by 210. And I get a nice clean 34.28. So 34.3. And I'm going to pause it and finish out the rest of the matrix, but you do as well. So pause it and fill it out. Okay, so I did the whole table. Hopefully you got just about these numbers. Now, you should be able to add these margins. When you add the margins, they should be the same as what you expected. Now, if you actually do this on this problem, if you add up the margins, you'll notice you're going to be off in certain categories by 1 decimal. And that really had to do with rounding. Specifically 42.9 and 12.9, those were supposed to be 42.85. They both got it rounded up, so you kind of end up with an extra decimal place at that point. But it's just rounding error. This is why the more decimals you could throw in, or the more places you can go in your decimal, the better and more accurate you're going to be. Okay, so those are the expected counts. State the null hypothesis if you want to pause it and give it a shot. If not, I'm going to answer it right now. The null hypothesis should be that age and vehicle type driven are independent. Versus, well, not HO, what's not HO, that we can write this out, age and vehicle type driven are dependent. In other words, there's some kind of, sorry, that's supposed to say dependent. What we mean by dependent, and usually this is what we hope to show, that there's some kind of relationship with in this case, with either within age or type of vehicle that makes the distribution not uniform. So what does that mean in this context? Let's just kind of go back to where I had my labels. Well, I think we kind of clearly see that older people tend to not drive motorcycles as much. Okay, that makes sense. Older people drive sedans and others, while it looks like younger people maybe are more inclined to drive sedans than older people. If you see a little switch between more young people drive sedans than let's call them middle-aged, and more middle-aged people drive other vehicles than younger people. Okay, so check the requirements if you want to give this a pause. Okay, what are the requirements again? Funny you should ask. All expected counts are above 5. Okay, this is Mr. Bessling making up problems. I did this again. Is 5 greater than 5? Not technically, but we're just going to roll with it. All expected counts. I'm going to kind of cheat a little bit, and I'm just going to say are greater than or equal to 5, because that's true. 5 is equal or to or greater than 5. Calculate the chi-squared statistic. So if you know how to do it, maybe you want to pause this screen and try it. If you want a little pointer or a little hint, I'll give you a little hint. The chi-squared statistic is the sum of all the observed minus the expected squared over the expected. I hope you have that matrix written on your paper, because it's going to be hard for me to go back screen to screen. So hopefully you have both of these matrices written. Now for the expected, it's going to be annoying, and we're going to have to do 9 separate calculations and add them together. But I'm going to take my first cell, the observed was 45, the expected was 40.5, and square it and divide it by the expected. So that would have been 45 minus 40.5 squared divided by the expected, and I have to do this for every single cell. Now what I'm going to do here instead is I'm just going to subtract the observed minus the expected in my head, because it's going to be slightly more simple. So I'm going to do that. You try it too. Pause it right now. I'm going to write down most of my calculations. So again, it was the observed minus expected squared divided by the expected plus the next cell. For instance, if you just look at the first term, 40 minus 40.5, that's going to be 4.5. Then I'm going to have to square it and divide it by the expected 40.5. And then I have to do it 9 times, add them all together. Okay, have fun with that. I'm going to have fun with it too. So I got all of these values. Now, a few things to notice again. I just did the observed minus the expected in my head. Hopefully I didn't make any mistakes. Hopefully you got the same thing. I haven't added them together yet, and I don't actually have my graphing calculator, so I'm going to let my computer do it, and my numbers might be slightly different than yours, but it should be close. So a few things to notice. I negated all the negative signs, because we take a negative, even if we have a negative number, once we square it, it's going to become positive. And also, if you see, the second to last term was 0, which was nice, and that was that the expected, whereas 5 was observed and 5 was expected. Notice that I didn't even write the denominator because 0 divided by anything is just 0. So I'm going to add all these numbers together now, or at least use my computer to do it, so you try too. So after adding all these together, I have a chi-squared statistic of about 5.308, or yours is probably going to be somewhere around there. Hopefully not far off. Okay, so what's the p-value? P-value, it's a right-sided test, so we're looking for the probability that chi-squared is greater than, what was it, 5.8? It's 5.308. So that's going to be, my cats are playing, chi-squared CDF 5.308 to infinity. So we'll put 999. Now, how many degrees freedom? If you remember, see if you can figure it out. It's the number of rows minus 1 times the number of columns minus 1. There are 3 rows, there are 3 columns. So it's going to be 3 minus 1 times 3 minus 1. We have 4 degrees freedom. You wouldn't really see 4 degrees freedom. I don't know, I don't really think 4 degrees freedom, but I have this little, weird little, I wouldn't say trick, but if I look at this is a 3 by 3 matrix, so I could tell how many degrees freedom it is if I take 1 row out and 1 column out. So that is the corresponding 4 here. I don't know, it's just my thing. It's a kind of fun way to see it. You just like kind of get rid of 1 row, get rid of 1 column, and that 4 is how many degrees freedom you have. It kind of always works. So for that p-value I got, and hopefully you get something pretty close to this too, 0.2571. Okay, so what's our decision? Since the p-value is greater than, okay, I'll write it. You guys have to be sick of me writing this by now. Since the p-value is greater than alpha, we fail to reject the null hypothesis. That is, there is not convincing evidence. There is not convincing evidence that age and vehicle type are dependent. That age, oops, I forgot my and. Vehicle type are dependent. And we're done. We had fun. That was a great time. I'm glad you enjoyed it, and I will see you guys in class soon.